This is lecture 6.2 or section 6.2 for the lecture video series for online college algebra at Wayland Baptist University. We finished off 6.1 having talked about how to multiply and divide rational expressions and rational functions. Now we're ready to continue working with those rational expressions by talking about how we add and subtract those. Now it turns out, I've said this a number of different times already in the first video, but these types of operations are very similar, if not identical, to the types of operations we do on regular fractions, fractions that don't involve variables in the sense that they're numerical fractions. So that if you can add, subtract, multiply, and divide fractions, we're going to be doing the same thing. We just now adapt those rules to include the cases where our numerators and denominators have variables in them, that is, that they are polynomials in fact. With that, let's get started on how we add and subtract rational expressions. Let's start by talking about how we add or subtract expressions that already have common denominators. You'll remember from working with numerical fractions that whenever we want to add two fractions together, we first require that the denominators of those two fractions be the same. Okay. In order for this to be able to add them, we're going to talk about, we're going to make sure that those denominators are the same. Once we do that, we write it over that same denominator, but then we add up the numerators. That is, we add the numerators together and put it as one numerator over that common denominator. Similarly, if we have a common denominator and we are subtracting, then what we do is we subtract those numerators, a minus b, to create one numerator over that common denominator of c. Okay. Well, that's going to be true whether we're working with a, b, c being numbers or if they're polynomials. So to add or subtract with common denominators, here's what we do. We add or subtract the numerators, and then we simplify. Simplify meaning what we did in the last section where we factored the numerators and denominators and canceled out those common factors. Now, just as a side note here, let me make sure everybody who's listening to this video knows why we do fractions this way. You may have always just been told to do it. Why do we actually have a rule that says that's how we have to add fractions? Well, think, for example, if you had a pizza. Okay, here's our pizza. Okay, and that pizza has been cut up into so many pieces. Let's say we've got fourths. So we'll put a piece here. I'll draw another line. Actually, let's do it in sixths. So I bet I can get a line here, and then another line to go this way. Okay. So let's say I have 1/3 of that pie, that right, or sorry, 1/6 of that pizza, right? That represents, or this piece right here is 1/6 of that whole piece. And if I want to add to that two more pieces, that if I group them together and say, all right, here I want to consider 2/6, how much of the pizza do I actually have? Well, the denominator in each of these fractions we're not going to add together because that represents how big my piece is. If I want to take 1/6 and add it to 2/6, it's the numerators that I add together because those are the number of pieces that I have. The numerator is the number of pieces. The denominator is the size of the piece, the size being 1/6 of the whole. So we end up with 3/6 or 1/2 of the pizza when I add that all together. So it's the size that has to be the same. If they happen to be different, if I take 1/5 plus 1/4, I can't just add the numerators because I'm talking about different sized pieces. I can't say how many fifths or how many fourths of the pizza I have. I have to find another denominator that matches and somehow work with that new denominator. But in the case that they're the same, all you have to do is add up the total number of pieces that there are. In this example right here with the polynomial that you see right here, notice how the denominator is the same in both cases. So all we got to do is take 3 plus x minus 4 all over x plus 2. We're going to combine like terms in the numerator. I'm going to be left with x minus 1 over x plus 2. I have now combined those two fractions into one. The only difference between this problem and the previous problem is that we're now doing a subtraction problem. That is, we have this minus sign in between here. So we again have a common denominator, so we can write this as x plus 5, x minus 3 in the denominator of our answer. But now we've got to subtract. Now here's the thing to remember. I am subtracting this whole numerator minus this whole numerator, which means I have to be careful. If I'm going to subtract the whole thing, I actually have to subtract every single term. It looks like this. I'll have an x squared plus 3x minus 2 minus x squared plus 2x minus 3. We talked about this back in the Chapter 5 review video. What you always have to remember to do when you're subtracting is always distribute the negative, right? Always, I can write always distribute the negative. You got to do that whenever subtracting. Okay, so in our case, the numerator now looks like this. We're going to have an x squared plus 3x minus 2. Now if I take a minus and an x squared, I get minus x squared. Minus and a 2x is minus 2x. And minus and a minus 3 is plus 3. All divided by x plus 5, x minus 3. Now we simplify. That is, we're going to combine like terms in the numerator. The x squareds subtract out. I have 3x minus 2x, leaving me with just a single x. I have a minus 2 plus 3 is a plus 1 over x plus 5, x minus 3. I cannot simplify that any further. So there's my final answer. Okay. Now the last question on this page asks, what if the fractions, the rational expressions, don't have a common denominator? Well, the answer is we find one. We're going to make it have a common denominator. To find the lowest common denominator, the first step we go through is to factor each denominator completely. In order to find that denominator that's the lowest but common to all, meaning that it's the denominator we're going to be able to convert all of our fractions to, we've got to start by factoring the denominator completely. And in doing that, what we start by doing is to find the LCD after we factored of the coefficients. If there's a GCF, just so you know what I'm talking about, that is, if there's a coefficient out in front of the denominator after you've completely factored it, we start by finding those lowest common denominators. I'm going to assume, at least for this point, although you'll see some of these in an example, so hopefully you'll catch on if you haven't got this down, that if I were to say add 1/2 plus 1/3, you guys know how to find the lowest common denominator for that fraction. That is, you're finding the number that both 2 and 3 go into. Right? One way to do that is to take the largest number and take multiples of it until you find a number that the smaller one goes into. In this case, 2 doesn't go into 3, but 6. 2 goes into 6. So the lowest common denominator here is 6. Right? So that's what we would then, convert these things to by multiplying in the numerator and denominator by the same factor that turns the denominator into 6. Okay. Well, if there's a coefficient out front, you're going to do that process with the coefficient. Now we got to talk about what do we do with all the x's and stuff that's in there. So we start by listing all the different factors that appear in any denominator. When the same factor appears in more than one denominator, we're going to write that factor to the highest power that appears. Okay? So we write all the factors down that we see anywhere, and if there's a factor that appears in more than one denominator, we make sure we put it to the highest power we see. The LCD then is going to be the product of all the factors in step 3, and in fact step 3 and step 2, meaning that that GCF that we found the lowest common denominators for. All right, let's look at an example. We've got 3 over 5x minus 2 over x squared. We want to find, for now, let's not even worry about subtracting. Let's just find the LCD. So what are the factors? Now again, remember, factors, if I haven't written this down already, I'm going to write it down now. Factors are separated by multiplication. Not addition, not subtraction, but by multiplication. So what's separating, what are the separate factors in the denominators here? We've got a 5, okay? That's one of them. I'm going to highlight it with yellow. And then what else do we have? We have an x. Okay. Now x is actually appears in both of them. In one of them it's squared, so that's the one we're going to use. We're going to use the highest power that it appears. So we have to make sure that our LCD has a 5 in it and it has an x in it, but x appears in both of them, so we're going to put it to the highest power that we see. So the LCD is 5x squared. When all you're asked for is the LCD, you're done at that point. We can go ahead and do example B, same way. We're going to find the LCD. We need to find the lowest common denominator of 18 and 27. So 18 and 27. What number do both 18 and 27 go into? Again, the shortcut that I use is I start taking multiples of the highest number. If I need my calculator, I pull it out and I divide in the smaller number until I get something that it divides evenly into. 18 does not go into 27. You take 27 times 2, you get 54. (27 times 2 was 54). And that one works. 18 goes into 54 3 times. So I know my LCD is going to have a 54 in it. I would have kept going until I found something 18 goes into evenly. 18 does not go into that, so that's why it's not available as my LCD. Now what about the other ones you see? I see x's, right? What's the highest power that the x's appear to? Well, they are cubed, right? X cubed is the highest power you see. And what about the y? We have a y here. We have a y cubed here. So the highest power we see is going to be y cubed. 54x cubed y cubed is our LCD. Now what you want to see here is you need to see something that you can take either of the denominators that appear in the original problem and multiply them by something that gets you to the LCD. The LCD is going to be bigger. Okay, it's going to have more terms in it, more factors I should say, than the original denominators themselves. Okay, notice this one has a bigger number than the 18 and has 2 more y's than the first denominator. So I could multiply the first denominator by, say, 3 and a y squared, and that would turn it into this LCD. So you want something that you can turn the denominators into. That's the important thing. Now let's look at ones that may have some pluses and stuff showing up in the denominator. Now in this case, we've got 2 different factors that we see. Now you may not recognize this at first, but this x right here is different than this factor x plus 5 right here. Now why is it different? Remember, factors are separated by multiplication, and there's nothing separating multiplication between that x and that 5. It's plus, like mortar between the bricks. It's held together. You can't break it into 2 pieces. So I've got 2 different denominators. That is 2 different factors. My LCD will list both of them. It has to have an x and an x plus 5 multiplied together. So x times x plus 5 is the LCD in that case. Okay. Next one, same deal. The x plus 1. That is a factor as a whole piece itself. Okay. It's raised to the 3rd power in the second denominator. And then the other one is an x. So we got an x squared and an x. So our LCD has to have an x in it, and it has to have an x plus 1. Now go back to the rule. What's the highest power that appears? X appears to a 2nd power. X plus 1 appears to a 3rd power. That, as a product, is your LCD. Now we need to do at least one that has denominators we actually got a factor. You'll remember the first step that we saw back on the previous slide was that, or on the previous page, was to factor. In all the examples I've given so far, you didn't actually have to, but in this case, we do need to factor first. We don't list the whole trinomial in there, 2 separate trinomials in the LCD. So first we begin by factoring, if we can, the first denominator. So that's going to be x and x plus and minus, I believe 3 and 4 will work there. And the second denominator is going to factor to x and x minus and minus, and a 3 and a 4 work there. So now we've got these 2 denominators. So the LCD will list every factor that we see there. So we can take an x plus 3, we see an x minus 4 that shows up in both places, and we see an x minus 3. Ooh, that makes it hard to see. Let's try the green, see if I can see through that. Alright, there we go. So we have an x plus 3, x minus 4. Now, it's in both denominators. I see two of them, but I don't need two of them. I only need one because the highest power that appears is just one. I only need one of them. And then I also need an x minus 3 because that's different than x plus 3. And there is your LCD. Now, what do we do with those LCDs? Well, that's what we're ready to talk about now, is how we actually add and subtract these things that have these fractions that have unlike denominators. We're going to convert them into fractions that do have common denominators, and then we can go back and use the same technique we did before. So how do we convert them is the issue. Well, we start by finding the LCD. That is, in order to add or subtract when we have unlike denominators, we find the lowest common denominator. We rewrite each fraction with the LCD, which means you look at the denominators and you say, what's missing? Okay, multiply in the missing terms to the denominator, and in doing so, you'll have to make sure that you multiply the same thing to the numerator. If you do the same thing on top and bottom, you don't change the value of the fraction. Anything multiplied to the denominator must also be multiplied to the numerator. Okay. Once you reach that point, the problem is very much like what we had before. All we got to do now is leave the denominator factored. Don't multiply it out. There's no reason to. You're going to have to factor it again in the last step anyways. If you multiply it out now, you're just creating more work to do. So leave the denominator factored, but multiply out the numerator. Okay. Once you get there, boom, we got the same step. This is just like previous page. Okay, we add or subtract just like before. Just like the previous examples. Now, once we simplify, once we have it add or subtracted together, we then simplify, which means factor the resulting numerator and then cancel. Okay. All right, let's look at some examples. Step 1 is to find the LCD. So in this example, 2 over x plus 7 over y, we need to identify what the lowest common denominator will be. Since they're each separate factors, we're going to list them each, x, y, both to the first power. So x times y is the LCD. So now I look at 2 over x and I say, okay, looking at the x, what's missing from this denominator that makes it look like xy? And what's missing is a y. So I'm going to multiply in a y because it's what's missing. But if I do that, I've changed the fraction, right? I've changed the value of the fraction. So in order to keep the value of the fraction the same, I'm going to multiply by the same thing on top and bottom. Okay? 2y over xy is the same as 2 over x, is what we're going to say. Okay? And then 7 over y, same thing. What's missing is an x, so I'm going to multiply in an x, and what I end up with is 2y over xy plus 7x over xy. I know it says yx, but of course multiplication order doesn't matter. So 2 times 3 is the same thing as 3 times 2, right? Same thing is true for x and y. Yx is xy. So now we have a common denominator. We just add the numerator. So 2y plus 7x over xy. We can't simplify that any further, so that is our final answer. On B, again, we start by finding the LCD. We look at the 3 and the 9, and we notice, of course, that 9 is the lowest common denominator for 3 and 9, so 9. We need an A. It needs to be raised to the third power, and B needs to be raised to the fourth power, because that's the highest power that appears for each of those two factors. So there's our LCD. We are now going to rewrite our fractions in terms of the LCD. So 2 over 3a cubed. What do we need to multiply 3 by to get to 9? Well, we need a 3. We've already got a cubed, so we need a b to the fourth. So I'm going to multiply on top and bottom by 3b to the fourth. That will turn this denominator, 3a cubed, into a 9a cubed b to the fourth. Plus, do the same thing with the second fraction, 13 over 9ab to the fourth. I don't need any more numbers. I got 9 is already there. I do need 2 more a's, so a squared on top and bottom, and b to the fourth is already there. So I'm left with a 6b to the fourth by multiplying the first numerator out, plus 13a squared, all divided by 9a cubed b to the fourth. Now I can't factor the numerator or denominator in this case, so nothing cancels. I'm going to leave it simplified as such. In example C, we have an x minus 6 and an x plus 6 in those denominators. Nothing needs to be factored, so I just need to list each denominator. So I have an x minus 6 times an x plus 6 as my lowest common denominator. So looking at x plus 3 over x minus 6, the term that's missing, or the factor that's missing, I should say, is x plus 6. So I'm going to multiply in x plus 6. If I do it to the denominator, I have to do it to the numerator. Now I've got to multiply the entire numerator by this new factor that I've inserted, and that means I'm going to have to FOIL whenever I multiply this out. Subtract. I have a x plus 6 on bottom that I need to multiply by an x minus 6. So x plus 1 has to also be multiplied by x minus 6, because that's what's missing. So if we now distribute across the top, we have x squared plus 9x plus 18. All of this divided by x plus 6, x minus 6, minus, I have an x squared here, minus 6 plus 1 is a minus 5x, and then minus 1 times minus 6 is minus 6. All over the common denominator of x plus 6, x minus 6. Alright, so we now have this all over the common denominator, x plus 6, x minus 6. Take the first fraction's numerator and subtract the second fractions. X squared plus 9x plus 18. Distribute your negative. Always distribute your negative. Minus x squared plus 5x plus 6. So the x squareds cancel out. I'm going to have 9x plus 5x is 14x. And then 18 plus 6 is plus 24 over x plus 6, x minus 6. Even though I can factor out a common factor of the numerator, it won't cancel with the denominator, so I can leave my answer in this form. In this final example, example D, we do actually need to find the LCD by factoring first. So that we're going to look at this this first denominator, factor it into its components. We're going to take that and have an x times x to give me the x squared. They're going to both be minus. Two things that multiply together to give me 24, but add together to give me 10 would be a 6 and a 4. Okay, so that replaces that denominator. Now this last number, this plus 1 right here, remember we can treat any number as a fraction. So we're going to have 3 fractions added together, which means all 3 fractions now have to have a common denominator. So we look at those 3 denominators and identify the LCD. The lowest common denominator is going to have an x minus 6 in it. It's going to have an x minus 4 in it. And that's all, right? Anything multiplied by 1 is itself, so the 1's understood to be there. So now we look at each fraction individually and multiply in what's missing. So for the first one, nothing's missing. X minus 6, x minus 4, it's all there. Second fraction, 3 over x minus 6 is missing the x minus 4. So I'm going to multiply by x minus 4 on top and bottom. Plus 1 over 1. Everything's missing now, so I'm going to multiply by x minus 6, x minus 4 on bottom, and x minus 6, x minus 4 on top. Now each fraction has the lowest common denominator in it. I need to multiply out my numerators. Okay, so x minus 6 times x minus 4 is in the denominator here, still with the x. Minus, I'm going to have, distributing this, 3x minus 12 in that numerator with the same common denominator. Plus, now I need to multiply out this numerator. 1 times this is going to be itself. But now I can FOIL that, end up with x squared minus 10x plus 24, all divided by x minus 6, x minus 4. Now we can write this as one big fraction all over the common denominator, because We can combine all of those since they have a like denominator. So I'll have an x here. When subtracting, always remember to distribute your negatives. So minus both of these, you get a minus 3x plus 12 plus all of this numerator, x squared plus 10x plus 24. Okay, and then combine like terms. All right, so let's see. We got one of the x squareds here. We got the x squared there. We've got that taken care of. What about x's? I've got an x, a minus 3x, and a plus 10x. X minus 3x is minus 2x plus 10x is plus 8x. Got those all taken care of. 24 plus 12 is plus 36. All over x minus 6, x minus 4. I think I got something screwy here. Let me double check. This should have been a minus. I made a quick little mistake up here. Let's make sure we fix this. This plus does not change that. That should still be a minus. So let me fix that. Follow along with me here. Go back to your notes and make sure you take that out and make that a minus 10x. Okay, so what have I got here instead of 8x? I've got an x, a minus 3x is a minus 2x, and a minus 10x will make a minus 12x. Okay? Now we can actually simplify that further because we can factor the numerator in this case. It's x minus 6 times x minus 6 all over x minus 6 times x minus 4, isn't it? Right? You can factor that numerator. It's a perfect square, so it turns out to be x minus 6 times x minus 6. Just using reverse FOIL, I get that. Divide out the x minus 6's, and I'll have as my final answer x minus 6 over x minus 4. All right? Now, that concludes our section on adding and subtracting. So now we know how to find the domains. We know how to simplify, add, subtract, multiply, and divide rational expressions.